For the part B, we're going to just calculate the perpendicular or use the perpendicular distance between the two forces. That means this distance right here, perpendicular to both forces. Now, before we start, again, we're not going to use the full arrangement of the lever, so we can just focus on this section right here. Let's enhance it a little bit so we can see properly what's going on. Now, to do this, we're going to try to get exactly the same moment that we got from the last part. And we're going to do it by trigonometry. We gotta calculate this distance first. How do we calculate? Well, if you see, we can actually get a rectangle triangle that goes like this. Where this one right here is going to be my perpendicular distance, the one that we are looking for. If we can calculate this perpendicular distance, the moment of the couple is going to be calculated perpendicular distance times the force of the couple. That's going to be 40 newtons. How do we get there? Okay, I know these forces have an inclination of 20 degrees. So that inclination for this one is going to be exactly the same as for this one, 20 degrees. Now, we're going to build another rectangle triangle that's going to have this full angle. Now, this full angle, if you see, it's going to be exactly the same as the inclination of the lever, which happens to be 55 degrees. That means this inclination right here, 55 degrees. This inclination right here, the 20 degrees. They both, these two rectangle triangles share one thing. They share one hypotenusa. So I can calculate what's going to be this section right here that I'm going to call beta. Beta, it's going to be the full extension, the total 55 angle minus this small section, which is going to be the 20 degrees angle. So beta is going to be 35 degrees. That's giving me this section right here. If that's the case, we can build our rectangle triangle where this force of 40 newtons it's applied in here, and this force of 40 newtons it's applied in here. They are parallel, and I have the means to calculate this distance. Well, right now here the hypotenusa is going to be 270 millimeters. So the perpendicular distance is going to be 270 millimeters cosine, sine of beta, and beta 35 degrees. Perpendicular distance is going to be 0.586, or well, it's actually going to be 154.86 millimeters, that we can translate 0.15486 meters, where we know this one and where we know the forces. So the moment of the couple is going to be 0.15486 meters times my force of 40 newtons. Moment of the couple, it's going to be equal to 6.194, which is actually very similar to the one that we get. And the direction. Now that we calculated and we're working with this rectangle triangle, we see that we get a force in the upper side that goes to the right, a force in the lower side that goes to the left. That means we have a rotation like this, which is negative. So Newton's meters, negative rotation. Exactly or similar result only by decimals.